Let's take a look at this problem. We got f of x is equal to x squared plus 3 at the point 1, 4. And instructions say, find the slope of the tangent line of the graph at the given point. Our first step, we need to find derivative. And within that, we're going to have 3 substeps. Our first substep says to find f of x. Well, f of x is given. F of x is equal to x squared plus 3. Our second substep says to find f of x plus h. Now this is just evaluating a function, so we'll go back to our original function, x squared plus 3, and where we have an x, we'll put in a set of parentheses. So we've got parentheses squared plus 3. Now whatever's inside the parentheses right here is automatically we're going to put in right here, so this will be x plus h. Now x plus h squared is x plus h times x plus h plus 3. X times x is x squared, x times h is hx, h times x is hx, and h times h is h squared, plus 3, which gives us x squared plus hx is 2hx, plus h squared plus 3. Now our third substep. We want to find a derivative. F prime is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. So we got limit as h goes to 0. F of x plus h from 1b is equal to x squared plus 2hx plus h squared plus 3. Minus, and then we'll put a parentheses because that minus has to change sign of everything that follows it. And f of x from 1a was x squared plus 3. All over h. So we got limit as h goes to 0. Now negative out in front of a parentheses flips the sign of everything inside, so it's negative flip the sign of the x squared and of the 3. So we're going to have x squared plus 2hx plus h squared plus 3 minus x squared minus 3 all over h. Combining out like terms, we got x squared minus x squared, those are going to cancel. We got 3 minus 3, those are going to cancel. So we got limit as h goes to 0 of 2hx plus h squared all over h. Now notice up on top, those both have an h in common, so I can factor out GCF of h, and that leaves us 2x plus h over h. Now that I've factored that out, I can see I can cancel the h's. So we end up with the limit as h goes to 0 of 2x plus h. Well, now we're ready to plug 0 in for h. So that gives us 2x plus 0, which then gives us 2x. So that's our f prime. Step 2. Change our notation to m. So we change f prime to m. And then we're going to plug in the x part of our point. If we go back to our original problem, they give us a point, and this will be our x, and this will be our y. So the x part of our point is 1. So I'm going to come down here, and I'm going to plug 1 in for x. And then 2 times 1 gives us m is equal to 2. And that's our answer.